Hey guys, welcome back to my YouTube channel. Hope you are all doing well. So today we'll discuss about SFD and BMD. If VTU examinations are concerned, this question is definite over there. Okay, on the BMD and SFD topic over there. Okay, so sometimes VTU is asking 20 marks question on this topic, or sometimes 15, or sometimes 12 marks. If I consider the civil branch, for mechanical branch, if MOM subject is concerned, there will be definitely 20 marks or 15 marks question on this particular topic. Okay, let's take a simple problem over here so that you will understand concepts very better over here. So a simply supported beam of span 5 meter carries 2 point loads of 5 kilonewton and 7 kilonewton as shown in figure. Okay, see here 5 kilonewton and 7 kilonewton are acting on the simply supported beam. So what we have to do, draw SFD shear force diagram and bending moment diagram showing that showing the important values over there. Okay, first of all let's understand what does the shear force mean, what does the bending moment mean. Okay, and what does the shear force diagram mean and bending moment diagram. Okay, if definitions are concerned, so for the shear force, it is the algebraic sum of vertical forces acting to the right or left of any section. Later on I will tell you what are the sections, which sections we have to take in this question. So it is just the definition which you have to remember. That is the algebraic sum of vertical forces acting to the right or left of any section considered is known as shear force. Okay, I hope you are getting. So it is denoted by simply F. Shear force is denoted by SF over there. Okay, so the graphical representation of variation of shear force, that is called as shear force diagram. Okay, so you don't need to worry about the definition part. Later on when I solve this particular problem, you will easily understand what does the shear force diagram mean over there. Okay, and also the definition, if we consider the definition of bending moment. Okay, the algebraic sum of moments of all the forces acting to the right or left of any section. Okay, uh, is called as bending moment. Okay, and similarly the graphical representation of the variation of bending moment which we draw later on, that is called as bending moment diagram. Okay, so no need to worry about the definition part. You will not understand by the theoretical definition itself. Okay, once we solve this problem, we will try to understand what does this shear force mean over here. Okay, step by step we will try to solve this SFD and BMD. Okay, so three steps are here. You are already aware of the equation, equilibrium equations, that is summation of f of x means summation of horizontal forces is always equal to 0. This is the equilibrium condition. And summation of f of y is equal to 0. This is summation of vertical forces is equal to 0, and summation of moments is always equal to 0. These three are the equilibrium conditions which you have to use in this particular question. See here in this particular problem there are no horizontal forces, so we cannot take summation of f of x is equal to 0. This equation we cannot take here. Okay, next possibility is summation of vertical forces. See here, vertical forces are, suppose these are the reaction forces Ra and Rb, and this is again a vertical force. So we can take summation of this, but there are two unknowns, Ra plus Rb. So that equation is not too much effective to calculate the values, as two are unknowns. If one will be unknown, then then it is possible to take this particular equation. So in this question we cannot take this also. Now summation of moments is equal to 0. There is the possibility of taking this equation. Why? Let me tell you here. So step 1 is we can take summation of moments is equal to 0. See here, you can apply moments at A also and B also. It is your choice. So I am taking here, if I take moment on A. Okay, so moment on A is always equal to 0. You should remember moment at endpoints, or wherever you are applying the moment, at that point moment will be 0. As you already know what is moment, force into perpendicular distance. See here, if this is the force, what is the perpendicular distance on it? It is 0, obviously. Okay, so that is why we are taking moments at that particular point as 0, where we start moment over there. Okay, so some moment at A should be equal to 0. Then we have to take another moments, that is 5 for 5 kilonewton, 7 kilonewton, Rb we have to take moments. Okay, so I can write here, but I have to take summation. I have to sum these. So first one is 5 into what is the perpendicular distance from the A, that is 1.5. So simply I can write 1.5 plus next force is 7 kilonewton. So 7 into this perpendicular distance, what is this? 2 plus 1.5 is 3.5. So 3.5 I can take. Okay, then last force is this one. This is your Rb. But remember here one point, with respect to A, where we are taking the moment with respect to A, the forces which are acting clockwise. Okay, see here, this 5 kilonewton is acting clockwise here. I hope you are getting this one. Okay, clockwise. And with respect to A, this 7 kilonewton is also a clockwise over here. Okay, I have take so we take this as positive over here. Okay, once it is anti-clockwise with respect to a, you are taking movement at a, so this rb is acting anti-clockwise, so I have to take it negative with the negative value. Okay, so this is your rb into what is the distance, this is your total distance is 5 meter. Okay, which is equal to 0. This is the summation of moments. Okay, now calculate this one. So here I will calculate it. 5 into 1.5 plus 7 into 3.5, which is equal to 32. So I can take 32 is equal to this minus rb into 5 I will take on the right hand side, so it will become rb into 5. So rb I am getting here 32 upon 5, which is equal to 32 upon 5 is 6.4. So your rb value is now 6.4. Now it is possible to take this condition, summation of vertical forces is equal to 0. Already we take we get this value rb value. Now only one is unknown, that is ra value is unknown, so I can take now this particular condition, that is summation of vertical forces is equal to 0. Okay, so what are the vertical forces? See here, you have to take upward forces always positive, whichever the forces are upwards you have to take positive, whichever the forces are downwards you have to take that negative value. Okay, so see here I can take ra as positive just because it is the upward force, this is negative, so sorry downwards I can take negative 5, minus 7 is also negative. Okay, then this rb is positive upwards, so its value is given here, so plus 6.4, you will get ra value is equal, sorry this is equal to 0, so ra is equal to, this is minus 5 minus 7 is minus 12 plus 6.4 minus 12 plus 6.4, which is equal to minus 5.6. So ra value is, sorry, ra minus 5.6 is equal to 0. Your ra value you are getting 5.6 over here. Okay, this is all about your reaction forces. So this is the first step in SFD BMD problem. You are supposed to calculate ra value and rb value. Now I can write here the results, that is ra is equal to 5.6 and rb is equal to this one 6.4. You should make a box for it. Okay, now the another step, this is the first step. Okay, I can write here step first. Now step 2 is calculation of shear force. Okay, and then bending moment, then accordingly you can draw the figure over there. Okay, now see here we have to calculate now shear force calculation. As by definition I told you, the algebraic sum of vertical forces acting to right or left of any section is called as shear force. See here, now there we have to take sections. Suppose first of all I will take section this one AC, I will take this section. Okay, the summation of forces on the left hand side or the right hand side, if we consider, that is called as shear force. So my suggestion to you people is just go for that particular force which are the minimum ones. Okay, so and at the left hand side of this particular section only one force is acting, so take this one only. If you consider right hand side there are three forces, so it will be somehow lengthier one as far as examinations are concerned, so better to go for the left hand section, the forces on the left hand section. Okay, see here, shear force calculation I had to take summation of the forces which are on the left hand side or right hand side. Okay, so what is the force here? Only ra is the force, and you should remember here the rule is, suppose if this is the section, okay, if force is acting upwards on the left hand section, okay, so that is called as positive, you have to take that is positive. So if it is downwards on the right hand side of this section, that is also as positive, this is called as positive shear. Okay, this is your first case. Next case will be the, this is your section, this is your baseline. Okay, if force is acting downwards on the left hand side of the section, you have to take that one as negative. If the force is acting positive, sorry, upwards on the right hand section of the this one plan, so you have to take that is also as negative, so this is called as negative shear over here. Okay, I hope this is clear. Now on this behalf you just check here, I have taken this section. Okay, on the left hand side it is acting, force is acting upwards. See here, force is acting upwards, that means you have to take that positive if it is on the left hand of the section over there, so positive I have to take. So what is the value? Ra means ra we have calculated here, that is 5.6. 5.6, this is your shear force, shear force between A and C section. Okay, sorry, A and C I can write directly. So this is your 5.6 kilonewton. Okay na? Right, then I can take section between C and D. This is your section. Now C and D is here. So you have to consider the summation of forces on the either on the left hand side, either on the right hand side. So here I can take this one also, this one also, as two forces are there. So it is your choice whichever you take. So I will take here A and this one 5 kilonewton. So what is the summation of, so shear force between C and D, right? So what are the forces? If it is acting upwards on the left hand section, so that is positive section. So that is your 5.6 is the value, Ra value is 5.6, and then 5 kilonewton. It is acting downwards. See here, if it is acting downwards on the left hand, sorry, on the left hand side, that is you have to take that one as negative value. So I can write here minus 5 kilonewton, 5 kilonewton. Okay, so these are the forces on the left hand side. I can sum it up, that is your 5.6 minus 5, that is 0.6 kilonewton is the shear force between C and D, right? Next one is shear force between this one D and B. D and B, if I take this section, okay, so D and B. So what is the minimum possibility? That is on the right hand side only one force is there. I will go definitely for this case. Okay, so this is acting upwards on the right hand side of this section. See here, if it is on the right hand of the section, the force is acting upwards, you have to take that as negative. So I can write here as minus RB. RB value is 6.4. So 6.4 kilonewton is your shear force between D and B. I hope this is clear to you people. Now after the calculation of this shear force, I can draw the shear force diagram. Okay, first of all let us draw the same simply supported beam, that is your AB, C and D. Okay, this is your 5 kilonewton, this is your 7 kilonewton, this is your RA and RB. RA is equal to, that value is 5.6, and this RB value is equal to 6.4. Okay, this is your, now you have to proceed this line like this one. In the examination you should make this diagram on one sheet. Okay, that is full sheet you have to cover with this. Draw a straight line, proceed it. Okay, draw a baseline which is exactly equal to the this simply supported beam length. Okay, now I have to draw the shear force diagram. Okay, so what is the shear force between A and C section? So that is your 5.6 kilonewton. Okay, so I have to draw this one. You have to start from this A, this is your B. From A you have to take 5.6 kilonewton. Suppose I am taking here, it is not necessary to measure with the scale. Okay, so this is your 5.6 I am taking here. Then shear force C and D, that is 0.6, but up to the A and C you have to take this 5.6, correct? So proceed this line also, this line also. So there is always a straight or 0-degree curve slope over here. Okay, you have to draw 5.6 line here. Okay, then between C and D, this is your C and D. So 5.6 minus 5 kilonewton, that is 0.6 kilonewton. If I take here 5.6, so 0.6 will be somewhere here. You can proceed it with like this. Okay, then again draw a 0-degree curve. Okay, then like this one. Then last is D and B, that is your minus 6.4 kilonewton. So it is definitely on the below line of the baseline. Okay, if it is 5.6 is up to this, so I have to make the bigger length here, that is your minus how much, 6.4 kilonewton. Okay, you can draw like this line. Okay, this is your final shear force diagram for this particular question. Okay, you can hatch now lines. Hatching of lines is important to give the better appearance of the shear force diagram. This is your all about the shear force diagram, how to draw this. Okay, now the another part is the bending moment diagram. So let us do some bending moment calculations, then we can draw the bending moment diagram. Now see here, this is the bending moment calculation. If I take bending moment at A, it is always equal to 0. Okay, so why? See here, at moment at A, there is perpendicular distance is 0, force is acting, but perpendicular distance is 0, so I have to take bending moment at A is equal to 0, and also bending moment at B is equal to 0. So I can take here bending moment at B, it is also equal to 0. Now, bending moment at C. Bending moment at C, as per definition also, the algebraic sum of moments of all forces acting on right hand side or left hand side. Okay, so here you have to remember the rule here. Okay, if this is your section, okay, if the force is acting clockwise, you have to take that one positive on the left hand side. If it is on the right hand section, right half of the section, if force is acting anti-clockwise, also you have to take that one as positive over there. Okay, this is your first case. Second case is, if this is the section, if force is acting anti-clockwise on the left hand section, that is your negative value. If it is clockwise on the right hand of the section, you have to take also that one as negative. Now see here, bending moment at C, the summation of moments I have to take on the left hand side or right hand side. So I can definitely go for the left hand side, as only one force is there, that is your RA. It is acting clockwise with respect to C. See here, this is your force which is acting clockwise. Okay, I hope you are getting it. So this is your upward. So what I have to take here, this is your clockwise on the left hand section, I have to take it positive. So I can take here 5.6 kilonewton. This is your bending moment at C. Now bending moment at D is equal to, see here, bending moment at D, I will definitely go for the right hand section, only one force is there. If I take this one, so three forces I have to take, sorry, two forces. Where you are calculating the bending moment, so that force you should exclude over there. Okay, you should remember this one. Wherever you are applying moment, at that point, which for what force, whatever the force is there, you have to neglect that one. So that is why I'm talking here. I have to take only the right hand side force, only one force is on the right hand side, I will take this one. So it is upwards, means with respect to D, it is anti-clockwise. If it is on the right hand section anti-clockwise, you have to take that one also as positive, as per rule of the bending moment. So I can take this as 6.4 kilonewton. Okay, so this is your 6.4 kilonewton is your bending, sorry, 6.4. When you are taking bending moment, you have to take also the distance. So sorry, see here, this is your C point. If I am taking RA value, that is your 5.6 multiplied by distance, that is your bending moment. Sorry, 5.6 into this one 1.5, and this 6.4 into what is the distance, 1.5 again. Okay, now I have to calculate this one, that will be your bending moment. So don't be confused. So this is your 5.6 into 1.5, which is equal to 8.4 kilonewton meter, and this one 6.4 into 1.5, 6.4 into 1.5, which is equal to 9.6 kilonewton. This is all about your bending moment. Now it is the time to draw the diagram, bending moment diagram. Okay. So see here, I will just proceed this one. You have to draw it straight in examination. I'm making it here roughly so that it will save my time. Draw the baseline. Okay, it's not necessary to draw the baseline, but draw it so that perfection will be there. Now what is the value of bending moment at A? So that is 0. I can mark here as 0, and this is B point, it is also a 0. So what is the bending moment at C? 8.4 kilonewton. So I can take it, suppose here 8.4 kilonewton. Next is bending moment at D is 9.6 kilonewton. So see here, I will take 9.6 kilonewton meter. This is your 8.4 kilonewton meter. Okay, once there are the point loads are concentrated loads. Okay, see here, this is the point load. For the point load or concentrated loads, we draw the bending moment diagram as linear curve. Okay, or 1 degree curve, you can say that. Okay, you have to join this straight line over here like this one. Okay, and then again a straight line, sorry, this is your straight line, then like this one. This will be your bending moment diagram for this. Now you can hatch the lines. Okay, this is all about this particular question. This is your shear force diagram. You can write down here SFD, and this is your BMD. I hope this is clear to you people. Make sure you will share it with your all friends. So thanks for watching my video, and also if you have some doubts, you can ask in the comment section. Thanks for watching my video.